from Rajaram Babu Institute of Technology. Ma'am is an application engineer of ANSYS. She was associated with VIT University and Trishwan at IIT Mandi. She has also worked in the field of machine learning. Ma'am has 4+ years of industry experience. Ma'am has contributed and worked on improving precision of muscular massage using software applications like AI, ML, and DA. Ma'am is ANSYS certified professional from 2023-2025 for HF. She is also an ANSYS certified professional for 2024-2025 in RF Microwave Antenna Technical. Ma'am has published many books, papers in national and international journals. It is indeed our pleasure that you are here, ma'am. Now I would like to request HOD ENTC Dr. Jaya Gage ma'am to felicitate ma'am with memento as a token of respect and love from our college. I again welcome you, ma'am. And you can start with your session. Thank you.
Hello everyone, good afternoon. So how many of you already used ANSYS HFSS, high frequency sector simulator? It's very new to all of you. Okay, so I'll give some background of ANSYS and then I'll start with the simulation. Day before yesterday, Gandhi's session is done and then Dr. Arvind Kumar was there. So continuing with that, I wanted to give hands-on in high frequency structure simulator tool. We will design some antennas and a reconfigurable antenna, how we can design, what is the basic behind that and how does it will work in simulation. That part I'm going to cover. So ANSYS started 50 years before with Navy's textbook equation. Mainly it was for mechanical engineering department, and then slowly it has gained ability to solve the Maxwell equations. So in that mainly all four Maxwell equations started with Maxwell tool. We have high frequency tools in that. Maxwell is one of the tool, and then slowly it has gained ability to solve the problems related to RF also. It's not going in next slide. So here you can able to see ANSYS is number one in simulation. You might have used other tools, but if you are looking accuracy. This is number one simulation tool in all simulation industry. And these are our area of work. Few you can mention, you can see here on the screen. So mainly we are working in automotive R&D. Then in mechanical department we have so many streams. This is ANSYS portfolios. You can able to see these are the different ANSYS tools which are available in different domains. So first department you can see that is materials. So in the materials we have a Granta. Granta is mainly used for the material designing. So we all know in antenna material is one of the important part. We all are familiar about FR4. Similar to FR4, with respect to different applications, in this Granta various materials are available. So those working in radar, so for that purpose they require a particular dielectric constant, particular tan delta. So all those values we could able to access with different uh, materials over here using Granta. So apart from Granta we have Granta selector, Granta MDS, Granta EduPack mainly for education purpose these tools are meant. Then next one we have embedded SUS. In that those are working with EV, electrical vehicle. These are the important suit or tools you can able to see. So here you can able to see skate suit. In electronics, mainly there are three streams. We all know. One is RF, one is embedded system, and next one is VLSI. So all these three, we have three different uh, department or segments you can able to see. Embedded suit is mainly for embedded softwares. For VLSI we have semiconductor, and RF we have electronics. So I'm not going in deep with other domain because structures and fluids they are fully mechanical. For photonics and optics we have optics, photonics and ZMAX. These are the main important tools. And digital twin, all real-time electronic system, whatever you can able to see in front of you. Those firstly we tested in twin builder and then we go for a fabrication. So all electronic system design we can able to do using twin builder. And today we are focusing on electronics part. That too in electronics there are again so many tools, mainly HFSS, SIWave, IcePack, Q3D extractor, EMC plus, Charge plus. Then we have Simplorer, Maxwell. These are the all tools in high frequency. And in electronics, mainly for antenna designing, metameter designing, unit cell designing, we are using HFSS. These are our commercial clients using ANSYS platform for R&D and project designing. These are our all academic customers where ANSYS tools are used for the research purpose. So all IITs, NITs, triple ITs, and all states top institutes are our clients. So today I am very happy to deliver you FDP. This is 87th FDP from my end. All over India I am traveling for the FDP. They will invite us for FDP. So I am very happy to deliver this session here as well. So in the high frequency tools, we have HFSS, which we all know. Next one is SIWave. SIWave is mainly dedicated used for the PCBs. So we already use Arduino board or Raspberry Pi boards. The boards which are available to find out the signal integrity, power integrity analysis, I diagram analysis. Then we are using this SIWave tool. Next one is IcePack. So again, Arduino Nano Raspberry Pi board we all know. Whenever excessive voltage is supposed unknowingly applied to the board, there is high chance IC and the components are getting heated or sometimes it will get burned also. So that situation should not happen for any of the PCB. That's why we all are using IcePack tool for thermal management part. So here in IcePack, it is helping us to predict airflow temperature and heat transfer in IC, PCBs and all electronic components. Basically this is CFD solver. Those are mechanical, they are having interdisciplinary work. They might have know about the CFD. CFD is one of the ANSYS tool. So this IcePack is useful in mechanical engineering also, electrical engineering also, and electronic engineering also. If I am talking about academic session. Next we have Q3D extractor. The day before yesterday, Gandhi sir was talking about parasitic extractions, right? So all the parasitic extractions on the PCB, whatever transmission lines we could able to see on the PCBs, their values like RLCG values we can able to identify using Q3D extractor. Next one we have EMC plus. So all cable related analysis we can able to do in EMC plus, where crosstalk analysis or EMI analysis of the cable, if anyone want to do in simulation, this is one of the important tools. And then last one is charge plus. So I'll give you one real-time example and then you can understand how this charge plus is working. Suppose drone is traveling from one place to another place and suddenly environmental condition got changed. Thunder started, rain started. In such a case, PCB, there are actually, this tool is working with two paths, charging and discharging path. So whenever such environmental conditions are getting changed, it should go in discharging path. And that's how it will able to save the internal PCB structure. That's why charge plus is very much useful. So this is mainly we are using in aerospace defense applications where radar or aircraft related work is there. That time this tool is very much important. And these are our different application areas you can able to see. And these tools are mainly high frequency tool if I'm talking about. It is helping us in wireless communication, smart devices. Then we have industrial equipments, power electronics, biomedical engineering, automotive industry, etc. So if anyone want to design antenna, HFSS is one of the important tool. Then multiple antenna communication we can able to do in EMIT, that is electromagnetic interference. That is also one of the part in ADT. If time permits, I will show that part also. We all are using mobiles, so you might have familiar about SAR analysis, specific absorption rate analysis. That part also we can able to do in ANSYS HFSS tool. Radar cross section analysis also we can able to do in ANSYS HFSS tool, bistatic RCS, monostatic RCS. That simulations or radar reduction. If we have multiple antennas on aircraft or any aircraft kind of body, then in that how RCS is going to reduce, and RCS related all simulations we can able to do in HFSS plus some Python coding also required. Now apart from that, signal integrity, power integrity analysis we can able to do in SI wave. Then parasitic extractions I already discussed about this. This is we can do in Q3D extractor. And you can able to see here in the red outline all the tools are available, that is high frequency tools, and in the yellow outline these are low frequency tools. These are mainly used in electrical engineering department and these are mainly used for the electronics department. Further, according to syllabus, they can use these tools. Now, whenever we are designing any antenna, this is the overall flow chart. We all know, whenever we are starting designing any antenna, first step would be to find the parameters of the antenna. Okay, so you all have gone through these equations. How to find out length and width of the antenna. For that purpose, we will use directly equations and we can able to find out length, width, height of the antenna. Again, we have to figure it out what kind of material we are going to use. Based upon material also, the size of antenna is getting changed. So we all know as dielectric constant is increasing, it is helping us to reduce the size of antenna. I think no need of mic, I can manage with this. So here, first of all, whenever we are designing any antenna, we first create a geometry. Yes. So we'll first create a geometry. Once the geometry is done, first step we are giving solver. What kind of solver we are using here? So generally FEM solvers are more preferable for the normal antenna design. If the electrical side of the antenna is going to increase, that time you have to choose these remaining solvers like HFSS IE solver, SBR plus, DDM solvers. I will tell you in coming time how SBR is useful. Whenever antenna placed on some different object like antenna placement and core. So in that case, SBR plus is useful again for aircraft or small helicopter kind of structure will be there. There if you want to put the antenna, that time HFS's IE solver is more preferable. So likewise, these are the overall flow where we can able to design the antennas. And once it is done, solver is ready. There are basically two parts: pre-processing and post-processing. In the pre-processing, we have a designing part, and in post-processing, we have to see what kind of results we are getting here. Maybe as parameter, gain, radiation pattern, etc. And once, suppose I want to design it with 2.4 gigahertz operating frequency, I'll design with the length, width, height of the antenna using geometry, and then I'll apply solvers, I'll apply radiation box to it, operating frequency, and I'll run the simulation. Once the simulation is ready, I will see yes parameter. If it is giving exactly resonance at 2.4 frequency, we'll stop there. Otherwise, we'll do optimization of that particular antenna. These are the other applications in HFSS we can able to design, where HFSS 3D is one of the part that is actually not in curriculum in academics. I'm not going in deep. We are in industry. We are using HFSS 3D rigorously. So these are the other applications we can able to design. Next tool is SI wave. So where SI wave is, I already explained, this is mainly for PCB we are using, where signal integrity, power integrity, EMI analysis we could able to do using SI wave. So real-time application for Q3D extractor, our mobile touch screen, then connectors, bus bar, transmission line, cable characterizations, etc. EMIT again, when on the aircraft more than two antennas will be there. Then if you want to see how much radiation is happening there, how much gain or how much transreceiver communication is happening, that time we are using EMIT tool. IcePack, this is one of the important tool for thermal management part. We can able to do management of chip or IC packages, PCB boards, or system level. Also, we can able to do simulations in IcePack. Apart from that, supercomputer or server room, anyone want to design, or real time if you want to implement the same server room kind of design, that also we can able to see all the thermal management of that room in IcePack. So this is about the cable. We all know in cable how many sheets are there, how many layers are there. So if such a complex scenario is there for any cable, in that case, if you want to find out radiated emission or crosstalk analysis, that time EMA 3D cable. Before the name was EMA 3D cable. From last year, this name has changed. EMC plus. So here we can able to find out radiated coupling to cable, radiated emission from cable, then EMI crosstalk analysis, EMI MC analysis of the cable. These are some applications of charge plus. One example I have already shown to you, that is about drone. Apart from that, we have arcing in HV systems, EST gun, PCB flashover, solid dielectric breakdown, lightning attachment module, and HV switches. New heart filter, those I think in second year of second semester, linear integrated circuit one subject is there. So in that, different filters probably they are teaching. In that, we are using new word filter. Here, this tool is very easy, where you can able to design all type of filter, low pass, band pass, passive, active filters. You have to just give operating frequency, what kind of filter you are looking for design. You have to select here and just run the simulation. You will get desired filter. Now, this is one of the important slides. Those are very new to the software. For them, ACT extension will help a lot. So, I'll show you once the tool and everything, that time how ACT extension is useful. Here, more than 22 types of different antennas are available. You can start, if you don't know how to use HFSS, you can start with ACT extension. Here, you have to go to HFSS antenna toolkit, and then you have to just click whatever antenna you want to design. So, go for dipole antenna, monopole antennas. Then we have horn antennas there, microstrip patch antenna, circular, rectangle shape. Many different antennas are available. You can explore. If you are using student version also, you can go through it. These are some examples where high frequency tools are useful. In the first figure, you can able to see one of the PCB where signal integrity, power integrity has been done. In second figure, you can able to see, actually animation is not working. So here, vehicles are traveling from one place to another place. In that case, you can able to see radiation patterns, how the radiation patterns are getting changed. That kind of simulations also we can able to see in ANSYS high frequency tools. This is the 3D filter example. Here you can able to see RF coside in aeroplane. Here more than two receivers would be there and one transmitter would be there. In that case, how the scenario will be. That kind of simulations you can able to see. This is the smartphone biocompatibility. So what is meant by biocompatibility? Anyone can tell me what is meant by biocompatibility? Hmm? Okay. Anyone else? So whenever any device comes contact with the human body, due to that external device, human body should not get affected. That's why we are this biocompatibility term comes in picture. That's why whenever on there are three parts: on body, off body, and in body. So all these three kind of antennas, anyone want to design in that case, biocompatibility comes in picture, and we are uh, designing accordingly, and we are checking SAR analysis also. So there are so many parts where biocompatibility, again material finding is one of the important part. Those materials are compatible to human body. If you are looking for implantable antenna design, that time you will consider biocompatible material also for designing. And the next one is antenna placement. So you can able to see this is a car CAD model. In left rear of the car, I have placed pipa antenna. And that pipa antenna, how the gain and radiation patterns are getting changed. If you are putting in some particular object, how the radiation pattern, E plane, H plane are getting changed, that kind of analysis we can able to see here. So this is one of the example where SPR plus solver is useful. This is for antenna placement. Again, in 1G we had voice communication, in 2G we had voice and text communication, in 3G we had voice, text and internet communication, in 4G voice, text, internet and multimedia communication came, and then 5G is most fastest way of communication where connectivity is very fast. This is one of the case study where Qualcomm is one of the company. I hope you all are familiar about the Qualcomm. This is our client. They have used ANSYS softwares for antenna designing and thermal management part. They have done using ISPAC. So this is one case study. So whenever we are designing any model, we are mainly focusing on three parts. First one is to find out its performance. Again, the size is one of the concern, and the last one is time and cost. So these are our other family or other portfolio tools where semiconductor related work, if anyone is doing, they can use radar, rafter edge or radar XC tool. In academic, tools are very much important. In case of EV related work, skate suit is one of the important tool for academic purpose. And if anyone is doing work in optics, photonics, in that case, PAOS, CMAX, and numerical, these are the important tools. And now one of the important thing I wanted to tell you, there are two platform ANSYS is providing. One is free, one is paid. The free one is ANSYS Innovation Courses. So here more than 189 plus from this July, 189 plus free courses are available, and those 189 courses are fully in RF domain. From basic to advanced level, you can register with any Gmail account and you can see all the courses. Each course will not take more than 3 hours, 1 to 3 hours, different timing each course has, and you have to complete 20 marks, one quiz. Once it is done, you are getting passed, suppose, then you get certificate. So you can use this certificate like in PTL course how you are using, or you can suggest to your students also, so that those are interested in RF domain, they can go for this courses. Apart from that, LH ANSYS Learning Hub. This is one of the big platform where all ANSYS different tools are you can access at one hub. More than 1,000 plus courses are available, different workshops are available. You can able to access that using ANSYS Learning Hub. There also you have to, but for that you need to get a separate subscription. And your institute, from the institute, we will generate one email, and that you can use for ALH access. Those are interested to develop labs in the institute. This is one of the slides for them. If anyone want to design they want to create an antenna lab for that purpose, at least these tools they should have. ANSYS, HFSS, EMIT, iSpec, U3D extractor, and ANSYS circuit. If anyone want to design PCB simulation lab, in that case they require SI wave and plus all remaining tools like ANSYS, HFSS, ANSYS, iSpec, and so on. For RFI lab, they should have EMIT, HFSS 3D layout, iSpec, SI wave, EMA 3D cable, EMA 3D charge. Since this is EMC plus filtered work, so EMC plus charge plus also will come in picture. And these are the remaining labs. If anyone want to take photos, they can take photo, and accordingly they can develop the lab. I already discussed about AIC. This is directly you have to type on Google ANSYS Innovation Course. This kind of window will open. Here we have to just log in with or sign up with any Gmail address, and you can access the courses. So in this July 2025, we have 189 plus courses in AIC, and this is the ALH platform. You are able to see this is the ANSYS campus, and here this is the electromagnetic building. So in that we have more 7 departments inside that, and you can access the courses in that campus accordingly. So let's move towards the designing part. I would like to start with antenna designing part, hands-on session. I have already given overall background of ANSYS if you are new to this tool. So we'll start with flexible antenna design. How many of you already use ANSYS HFSS tool? Can you raise hand? Nobody used. In the PCs, this student version is already installed or not? Okay, so you can start. Microstrip patch antenna, how many of you designed already? No, nobody of.
Madam, on other tool we have AWR also.
But okay, then we'll start with simple microstrip patch antenna. I'll show you how flexible antenna we can able to design, and then we'll go for the third design, that is reconfigurable antenna or reconfigurable. First, we'll start with transmission line. So go to ANSYS electronics desktop. You can able to see this kind of sign. Double click on that. ADT, ANSYS electronics desktop. Go to file. So first step would be go to project. I hope you already opened ANSYS electronics desktop. How to find out this window, I'll guide you. Once you are opening this software, go to project. In that, insert HFSS design will be one of the options. Insert. सगळ्यांना येतात येतोय का? सगळ्यांना येतोय सिक्युरिटी मेसेज.
हाँ वो क्या बोलते हैं कांचन मैडम वाला ये सर्वर ठीक है
इंटरनेट कनेक्ट नाही आहे ना त्याच्यामुळे
नहीं नहीं अभी लाइसेंस नहीं
server, please check server and there also they have to test. Ask ma'am to test it. Close, please close the window and then once again open. चालू? पासवर्ड काय आहे? वायफायचा पासवर्ड काय आहे?
तुमच्याकडे आहे ना वाईफाई कनेक्ट वाईफाई चालू आहे आता सुरू झालंय नाही होत तिथे पोर्ट पोर्ट काय मी इथे समोर हो करा ना समोर
I hope you have all these settings now. It is open on your desktop. So we are going to design this kind of structure. This is microstrip patch. We are going to design for 2.4 gigahertz operating frequency, ISM band, industrial, scientific, medical band it is. So majority of applications we are considering in ISM band only. So now there are mainly three parts while designing this antenna. First part we have to find out the parameters of antenna. Second part geometry design. And third part. So whenever first part comes in picture, parameters where length, width and height of the geometry plays a very important role. This is length, width, and this is the height. The substrate. So we are going to see here FR4 substrate. We all are familiar to this. So I'm considering FR4 substrate which has permittivity 4.3, permeability 1, and we are considering FR4 variant will come in three heights. One is 1.1 mm, 1.2 mm, and we all are familiar with 1.6 mm. This is easily available in market. We are going with 12.6. So we are going to design now length and height of the patch first. We have to find out this length width height of the patch. Of course, height of the patch we are using here copper material, so thickness will be always 0.035 mm. And we have our task is and width of the patch. So based upon the length and width of the patch, our frequency will be decided. So 2 pi under root LNC. So using this LNC, we can able to, if I'm changing LNC, it will again affect on the operating frequency of that. So this is our one of the important equation. So now I'm not going in calculation. I can directly use here microstrip calculator, where I have to give your input as a dielectric constant. You can use it on your laptop. Just type here microstrip patch antenna calculator and dielectric constant type 4.3. Height of the substrate I'm going to consider here 1.6 mm. And operating frequency is 2.4 gigahertz. So based upon three inputs, I'm going to find out here length and width of the patch. So here you can able to see length is 29.76 and width is 38.37. So this is the inputs I have received from this. So first, so length is approximately 29 mm and width is 38.37. You can take exact accurate also, and if you want to see parametric analysis, then you can use 29 and 38, and then you can do parasitics for that to get the results. Like if anyone want to use optimization technique, they can only choose 29 and 38. If they want to use exact these values, they can use exact at 2.4 gigahertz. They can get probably results. So let's start with the ground plane design. So for this design, which antenna I have drawn here, where length and width of the ground is 60 mm by 60 mm. So first layer you have to create ground plane. So go to draw and draw the rectangle anywhere in the plane. I hope you have all have this kind of screen. No need to check again, right? So go to draw, and here we have a rectangle. Just click on rectangle anywhere in the plane, drag it. Don't worry about the dimension, just drag it anywhere in the plane. I will show you where to do changes. Drag it anywhere in the plane. Just drag it. Once that dot is coming, just drag with the mouse. And just leave it. Rectangle plane will be created, 2D. Just drag it anywhere in the, just drag.
Draw with the rectangle.
Drag it now. At the center you keep and just right click on the mouse and just drag it. Keep it, it will be. I will tell you, because now this rectangle plane is drawn anywhere in the plane. Your XYZ plane will be exactly the center. Press Ctrl D so that your XYZ coordinate system you can able to see here. So now I'm going to give you here positions and XYZ axis size. For that purpose, you have to again go to in the model. Below rectangle one you can able to see here. I hope you all have this rectangle one. Just double click on create rectangle. You'll get this pop-up window. Here we have to assign the positions. So positions would be -30. Here you can able to see. Now it is -1.2, -1.02 and 0. So you have to type there. Remove whatever value you have in your pop-up window. I am also going to remove. And type there -30 mm, comma, -30 mm, comma, 0. So basically it is showing you XYZ axis coordinate values. So -30 mm, -30 mm, comma, 0. Next one, we are along the Z axis. So in front of axis you would able to see Z. Is it so fast?
Yes, मतलब डिजाइन इसमें नहीं आया वो कोऑर्डिनेट इसमें नहीं आया
Comma. यहाँ पे you just have to remove
बट अब तो रेक्टेंगल उसने कोऑर्डिनेट
comma
Rectangle alama,
minus 30
rectangle alama,
coordinate comma 0.
coordinates में
It is showing you x, y, z coordinate values.
double
But click on below this rectangle one, create rectangle is one of that option. Double click on create rectangle and in that first remove position values whatever available in front of your pop-up window and type there minus 30, comma minus 50, comma. Second point is axis. So we are along the z axis, no need to change axis. Third point is x size and fourth point is size. So in front of x size, type 60 mm. So it is basically length and width of the patch antenna. So again type the x size and y size 60 mm, 60 mm. I hope you have done. Now in front of your pop-up window, in front of your position minus 30, comma minus 30, comma 0. In the evaluated value, you were able to see minus 30 mm, comma minus 30 mm, comma 0. We are along the z-axis. X side is 60 mm and y side is 60 mm. Done. Click on apply. Click on OK. Press Ctrl D. I hope you have got this kind of geometry now. This is our ground plane. So now, see, whenever we are designing this kind of structure, either you can create 3 layers as the box or 2 layers as we have going to do. We have first created 2D geometry. Length and width only we are assigning here. Height we are not assigning. So we are assuming here height is 0.035. Whatever PCB we have seen till the date, so it will have top layer, bottom layer, mid layer. Top layer is copper, bottom layer is copper, mid layer is our FR4 or any substrate. So either you can design all these 3 layers as a box or 2 layers, top and bottom consider as a rectangle. Only FR4 we will consider as a height. Software is considering that 0.035 height. That's why I'm not separately giving. You can give. Instead of rectangle, we can here directly select a box and give height of the thickness of your copper layer is 0.035. That is T. It's up to you. But we can go with these two ways. Now our ground plane is ready. We can rename this. Whenever we are considering rectangle 2D geometry, that time no need to separately assign the copper layer. If you are considering 3D geometry, that time you need to assign each layer material. So when we are doing 2D geometry, it is automatically considering its copper layer. So I am going to change the name of the rectangle. This is my ground plane. Double click on rectangle. Before that, you have changed the values in create rectangle. Now double click on only rectangle and we have to change the name. Remove this rectangle one and type there ground plane. I hope you have got this. Since yes, ground plane. This is the copper layer. For my identification, I am going to select here color orange. Since copper is looking like that kind of color, so it's up to you. Can keep as it is also. And transparent, always keep 0.7. Click on apply. Click on OK. So our ground layer will look like this. Transparent 0.7. Minus 50, minus 50, comma minus and we are along the z axis, so we are not changing the z. Now we are having that X side is 60 by 60. 60. Y side is also 60. So ground plane line line width is 60 by 60. Click on apply. Click on OK. Press Ctrl D. It will come in the center of your plane. Now we are going to assign this to the ground plane. So I'm going to change the name. Here in sheet we have unassigned and here below rectangle 1. So double click on rectangle 1 and change that name. Type ground plane. Ground plane. Okay. Now since the ground plane is looking like a copper, so it's a copper layer. So I'm going to assign a color orange. You can choose any color. Transparent, it will show you the transparency of the 0.7 is the ideal value. 0.7 to 0.9 any value you can select. 7. Just click on apply and click on OK. Anywhere in the plane you click, you will get orange color on that sheet.
No, it is not taking orange.
Click on the top somewhere other place. I hope you have got this. Just click anywhere in this plane, you can get color change of your ground plane. Click on
So पहिले इथे guide
but consider rectangle 1 is your ground plane. This is the first layer.
One C.
Just save the design, then it will get changed. Anywhere in the desktop or any folder, save this design first. Go to file and save. Save with any name. Then your name will get changed. Please save your design, then only the name will get changed. हाँ सेव करिए डिजाइन आप पहले सेव किया फिर भी नहीं हो I hope you have done this. Name also changed. Okay, so let's design the second layer. That is our FR4 substrate. We are going to create the same length width FR4 substrate with only height is 1.6. So again, instead of rectangle, go to draw and select box. Draw and select a box. I hope you have done that. This kind of squares you could able to see on mouse pointer. So just click on any corner, drag it to the other corner, end it, and then you will see one arrow, push towards upper direction. I hope you have done this. Once again I will show you. Go to draw and select the box. Now you can able to see this kind of pointer. So anywhere in this plane, any corner, just click. Now drag it to the other corner, end it. Once again you have to just click on the mouse, and after that you could able to see one arrow. So move towards the upper direction. Shall I repeat once again?
Yeah.
Go to draw box, click on any corner, drag it to other corner, and then you will see one arrow move towards the upper direction. Arrows aren't coming. Arrows coming. Pop up. No issues, ma'am. Again, you have to go to box and you have to select that. Box one will be created.
Madam.
Box में. हाँ. एक second. I'll come. मैम आपको हो गया? बॉक्स आ गया. ये विंडो नहीं है. आपको बॉक्स वन पे जाके क्रिएट बॉक्स है ना, वहाँ पे क्लिक करना है. तब ये विंडो ये क्रिएट बॉक्स. हाँ, क्रिएट बॉक्स तब क्लिक करना है. नहीं नहीं, जो बॉक्स आपका क्रिएट हुआ है ना इनसाइड मॉडल, क्रिएट बॉक्स इज वन ऑफ द ऑप्शन दैट डेवलपिंग ऑन Select the dimensions of this box or will first finish P. कॉपी में कंटिन्यू करायचं का सब कंटिन्यू करायचं आहे. I tell you the dimension. So same is कभी I hope you will do. इसका position same रहेगा. -30. Now in the Z position we have to keep it height 1.6. तो हमारा सिर्फ यहाँ पे पोजीशन पे हाइट का चेंज करना पड़ेगा. तो I'll tell you the positions. Keep position for box -30, -30, 0. Don't change anything. Don't change the position. Only we are going to change. Just double click on create box. Double click on the create box. 1.6. Height of the substrate is 1.6. I didn't change anything. Like that, wait. Once again, I'll tell you the dimensions and then I'll apply. Your position should be -30, -30, 0. We are along the z-axis. Here x size is 60, y size 60, and z size you have to type 1.6 mm. Z only change in Z itself.
1.6.
1.6. Positions are minus 30 comma minus 30 comma 0. Then this is the first layer is our rectangle. So we are not going to change any position. We are only putting one another box on the top. That's why positions would be minus 30, and Z position would be same 0. Now on the top of this one more layer I am keeping. For this layer thickness is 1.6. So that's how just only Z size I am going to change here 1.6. Just click on OK. Click on apply and OK. Press Ctrl D. I hope you have this kind of geometry now. Yes. Now, again, this is the FR4 substrate. We only created a box. Now we have to give substrate details. For that purpose, double click on box 1. Before we have double clicked on create box. Now, since I want to change name and material properties, just double click on box 1. So you will get this pop-up window. I hope you have got this. Is it interesting or boring?
Very interesting.
Okay. So next one, when reconfigurable will start, now we will get a lot of much things, because using diode, we are going to change this transmission line characteristics. If we could able to finish it fast, we can switch on the next design. Okay. So here, box 1, rename this. Type here FR4. 4. Simply type FR4. So before going to the reconfigurable part, the designing would be same. Only the people are facing how to bend the layer. That part I will show you. Remaining part you do by yourself. Designing of flexible antennas. How you have to bend that antenna part. That I will cover. That I will show you how to do that. Then you remaining part you do. Then I will switch on the reconfigurable part. Any help? And save the design first anywhere on the desktop or any folder. Plus whatever layer you are going to do, press Ctrl S always. Exercise 60 and 1. So here we have to change the name. Type, remove the box 1 and type the FR4. Below that material you could able to see, and in front of that now you could able to see vacuum. Just click on that, edit option will come. So now the second step, we are going to design a material. We have to choose the material. Here vacuum you could able to see, just click on that vacuum. Edit option will, you could able to see, just click on edit, one pop-up window will come. This is a material library of ANSYS HFSS. You could able to see more than 200 plus materials are available in this library. I hope you have got this pop-up window. Type here, in search by name is available on the top. Type there FR4. So you will get these. Yes. So in that you have to select FR4_epoxy. And you can able to see here material properties, which includes permittivity, permeability, bulk conductivity, dielectric loss tensor. Now again, this is one of the important part. Those are doing research. Any conducting material is suppose there. In that case, this bulk conductivity we have to check properly. Any material you are looking for, if it is a conducting material, consider bulk conductivity. Now this is FR4 substrate, it doesn't have conductivity.
So my interest to see dielectric loss tangent. So this should be as minimal or as possible, then only loss will be less. So here dielectric constant value is 0.02 for FR4. Different material has different dielectric tangent values. Why I have included this point here? Because in case of radar, we want to add some layers. So in that case, since some absorber will be there, in that case we have to figure it out for the for those material its bulk conductivity and dielectric loss tangent. So generally for absorber, loss tangent will be more like 0.91 or more than 2 in case of radar applications. So these are the whenever we are designing or whenever we are choosing any material, bulk conductivity and loss dielectric loss tangent. These are the two important parameters we need to consider. Now just double click on this FR4 epoxy, click on OK. Now you will get one more time this window. You have to change the color if you want. I'm going to select this dark pink.
ठीक करता है ना
हाँ हाँ just click on apply, click on OK, press Ctrl. Any error or warning? Always keep transparent value 0.7 or in between 0.7 to 0.9. Done. 2 layers completed. Now shall we move towards the third layer? Third layer we are going to create a patch. Now we are going to design here insect feed microstrip patch. So this is nothing but insect feed. So for this geometry, first we create this patch. Again we will create separately this transmission line. This is 50 ohm transmission line. Here we will excite the port. And we have to create here insect feed. So basically this gap is acting as a capacitance, conducting part is acting as a inductance. So as we have seen, Gandhi sir talked about the resistor value in low frequency. This will not be applicable in high frequency since parasitic extractions are getting changed and toe value or this transient time value in high frequency is getting increased. That's why we are not preferring these components in high frequency. Instead of that, we are creating geometry so that it will act as a LC circuit. So basically, it is game of transient time. It is again actually what happens here when we are supplying voltage or input from this here. So again, it will go to like this. So from this point to this point, again voltage is getting changed. If you want to go in detail, you have to refer transmission line theory so that these concepts will be more clear. So now we are going to first create a patch. For that purpose, again go to draw and rectangle. Select a rectangle anywhere in the plane. So I have selected. Save whatever steps you are doing, save it again go to rectangle. This will be rectangle 2. Just double click on rectangle 2 and type there patch. Again, this is a copper layer. So here we have to again type a dimensions. For this 29 by 38 would be the length and width of the patch. Now, whenever we are designing this kind of structure, we have to always think about XYZ coordinates. Now, from the calculator, we have found that length and width is 29 by 38. But when I want to give a position, again, you have to consider, because this length and width is 38 by 28. I want this point coordinate. From this point, how much will be here and how much will be at this point to this point. So always you have to divide those parameters by 2. So the positions would be minus 20. So at 2.4 gigahertz frequency, length I am considering 29.4 and width is 38. So positions would be minus 29.4 divided by 2, comma, minus 38 divided by 2, comma, we are at the height 1.6. So 3 points we have to consider here. We already know length and width is 29.38. The positions would be minus 29.4 by 2, comma, minus 38 by 2, comma, 1.6. We are at a height of 1.6. So minus 29.4 divided by 2, comma, minus 29.4 divided by 2, comma,
minus 29.4 by 2
comma, minus 38 divided by 2,
by
divided by 4,
comma,
comma, 1.6.
minus 38.
38. Position is minus 29.4 divided by 2, comma, 38 by 2, comma, 1.6. Exercise is 29.4. Y side is 38. Minus 29.4 by 2. Comma, minus 38 by 2. Minus 5 comma, 1.4. Exercise is 28. Exercise is 29.4. Exercise 29.4. Y size 38. I hope you have got this kind of geometry now.
Exercise, what was the exercise?
29.4, wide size 38. All dimensions are in millimeter. Click on and plus click on it. Okay, so this is my we have bachelor, ground plane, and patch dimensions. I hope you have done these 3 steps. All of you done? So now we are going to create a microstrip patch line for 50 ohm. So this is the length and width. I'll tell you exact dimensions. So we first will create this rectangle slot, and then here we will apply um, Boolean function, so that unwanted part of that patch we could able to remove. So now go to draw, and again draw a rectangle anywhere in the plane. Now don't consider about the exactly it should be middle of that FR4 and I have to draw like that. Anywhere in the plane you draw, I will tell you the dimension so that it will come exactly at the center. So type. Now this is the feed line basically. We are going to create a feed line over here. So I'm going to give the name feed for this rectangle. So shall we start with position now? I hope you all got this pop-up window. So anywhere in the place, once again I'll repeat, we have to draw the rectangle now. So I hope you have done up to patch. This up to this I think everyone have done. Now just go to draw and select here rectangle. And anywhere in the plane, you have to draw a rectangle. Okay? Delete. Undo you can do. Directly select and delete. So its positions would be 0, minus 1.6, 0, minus 1.5, minus 1.6. 0, minus 1.5, 1.6. We are along the z-axis. Now this is exactly at the middle of this width. So this will be 30 and this width is 3 mm. So we are going to create a rectangle for this is a feed line basically. So this is 3 mm would be 30 mm, Y size is 3. So type the 30, 30, Y size is 3. So click on apply. I hope you have got this kind of line now. Once it is done, click on OK. Okay? So if you're giving wrong position, your microstrip will go, the speed line will go towards the ground plane. Positions are 0, comma, minus 1.6, comma, 1 plus 1.6. 0, comma, minus 1.5, comma, 1.6. Okay, up to this everyone have completed. Now we have to create inside feed. So at this place we have to again create one rectangle, and that rectangle we are going to remove from the patch. Boolean function we will use. So for that purpose, first save this, and you can change this now rectangle name. So this is a feed line. Again double click on rectangle 1, and instead of rectangle 1 type here feed or feed line as per your convenience.
Which rectangle?
Here rectangle 1 will be created, right? Double click on rectangle 1 and remove the rectangle 1, type name feed or feed line. Since this is conducting, again I am going to select orange color. Okay. So now we have to create inset feed over here. Shall I move forward? Shall we go to the next step? Same area, ma'am. Right. So माझं rectangle feed line आहे. तुमचं rectangle मध्ये feed line ला कुठलं rectangle shall we create that insert field section? So now what I'm going to do, I will create one more rectangle over here, and from that I'll remove that rectangle. I'll remove from this patch. So go to draw. I'll repeat this step 2 times. Just see carefully once again. Go to draw and click on the rectangle. Again, anywhere in this plane, just drag the rectangle shape. Don't consider about the position. I will tell you the positions for this. Once again, I'll repeat. Go to draw rectangle, draw rectangle anywhere in the plane. I hope you have also got this. Anywhere in the plane you have drawn this. Now, in this position, first remove this whatever available there. Type 30, comma minus 1.5, comma 1.6. Don't confuse in minus plus sign. Positions are plus 30 mm, comma minus 1.5 mm, comma plus 1.6 mm. We are along the z-axis. X size is 3 and y size is sorry. Positions are little modifications are required. Positions are 14.7, comma minus 2.5, comma 1.6. Once again I'll repeat. Its positions are for plus 14.7, minus 2.5, comma plus 1.6. We are along the z-axis. X size is minus 9.5 mm and y size is 5. Can you repeat the position? Yeah. So its positions are
minus x size
minus 9.5. Positions are 14.7 mm, comma minus 2.5 mm, comma 1.6 mm. We are along the z-axis. X size is 9.5 minus 9.5 and y size is plus 5. Click on apply. Click on OK. So you'll get this kind of geometry now. Cut. So we are going to remove this part from the patch. I hope you have got this kind of structure now. So we are going to remove this part. Double click on in my case it is rectangle 2. You check which is your rectangle 1, 2 or whatever it is. Just click on that and I'm going to rename this as a cut because I want to remove this from the whole geometry. So you can see inside my unassigned sheets, first one is cut, next one is feed, next one is ground and another one is patch. So you also will have 4 names. I hope you have done all these steps. Done, right? Now from this patch, this is the patch outline. First you have to select the patch, press Ctrl and then select the cut. This is one of the important steps. Please check here carefully. Press Ctrl D first so that geometry will be in front of you. First, I am going to select the patch. Just click on patch, press Ctrl, and at the time select the cut. So you can see here, in my case, 2 rectangles automatically selected. But don't select first cut and then patch one. First, always select from which part you want to remove what part. That you have to consider. So first, my base is patch. So I have first selected patch. From patch, I am going to remove this part. So press Ctrl and select the cut. 2 rectangle geometries I have selected at a time. Go to modeler, then select go to boolean and click on subtract. Once again I'll repeat. From this unassigned sheet, first select a patch. Press Ctrl and select a cut. So two geometries will be selected over here. Then go to modeler, go to boolean, and in that click on subtract. So it will ask you, one pop-up window will come, it will ask you in the blank part and tool part what are the rectangles you have selected. In the blank part we have to select a patch, and in the tool parts cut rectangle should be selected. Click on OK. You can see from the geometry that particular part will be removed. Got it? I hope you all have done this step. Yeah, I'll repeat. See, in your sheets, you have 4 sheets now: patch, ground, feed line, and cut. So, in this, first select the patch. Then, after selecting patch, immediately press Ctrl and select the cut. Two parts will be selected now. Remove this Control button. Go to modeler, go to boolean, and click on subtract. So in the pop-up window, it will ask you what parts you have selected. In the blank part, select patch. In the tool part, select cut. Click on OK. So this part will be removed. Done. How many of you completed? Okay. All. So now the second step would be to add these two. In this patch, I have to add this feed line so that this kind of structure will be visible. So again, we have to use boolean function. Here also, again select the patch first. Press Ctrl and select the feed. So you can see two geometries selected over here. Again go to modeler. Now we are going to add these two parts. So unite function we are using here. Go to modeler, go to boolean, and click on unite. You can see my both geometries are united now. Done? Size of feed line. Okay, so I hope everyone have designed the patch. Now we will excite the code. So for that purpose, again we are in XY plane. Change the plane, and here in this diagram you can see here, this is the slot I have created. Over here I am going to excite the antenna. So we have to again change the plane and draw this rectangle. Over here we have to create a lump code. So whenever waveguide is there, choose wave code. When antenna we are going to design, choose lump code. So we are in XY plane now. Here on the top you can able to see. So you have to select YZ plane. First change the plane. Instead of XY come in YZ plane. Press Ctrl D. And at this place we want to create a rectangle over here now. I hope you all are in YZ plane now. Okay. Again go to draw and go to rectangle, and from this corner to this corner drag one rectangle. No need to again consider about the size, I will tell you. But if you could able to draw exactly to the point, you can draw as I have done here from one point of transmission line to the other point of transmission line. You can see this rectangle have been created exactly to the end points. Okay, I hope you have done up to this. Go to YZ plane. Plane, if you are not changing your positions are same. You keep 30 comma 1 point minus 1.5 comma 1.6. Y size is 3 and Z size is minus 1.6. Now we will do code excitation. I hope you have drawn this rectangle. सगळ्यांनी draw केलाय? आता whenever we are going to design any geometry, first check what kind of solvers you have done. Position सांगायची गरज आहे का already? You have done, right? So again I'm not going to repeat about it now. Code. This is the code excitation. We are giving input to the antenna from this rectangle. So just rename this as a code. कलर वेगळा देता येईल का? हा येईल की. ते वेगळ्या कलर देऊ शकतो काय? आपला कलर आपल्या कन्व्हिनियन्स साठी आहे की generally what we have to do it, I just delete my code and once again I'll repeat. So you have to consider exactly at these 2 points, one line you have to draw and then drag to the bottom. So we have to create a rectangle shape over here so that connector we can put over here when we are after doing fabrication. So that's how we have exciting port here. So change the plane. Go to rectangle. Again, any one point first you have to select. I'm selecting this corner and just dragging to the other corner. I hope it is visible. So its dimensions are 30, minus 1.5 mm, plus 1.6. We are along the x-axis now in YZ plane, and Y size is 3, Z size is minus 1.6. Click on OK. Save. Now we are going to excite the port. For that purpose, go to HFSS, select solution type. So as I said, solution type plays very important role. These are the different solution types available. HFSS with hybrid array, transient, eigen mode, SPR plus, and characteristics mode. So different applications we are going to select. Since this is a small antenna model, HFSS, this is HFSS FEM actually. So you have to select HFSS. So basically HFSS is nothing but HFSS FEM. So select this HFSS in solution type, and below in the options we have two parts. First, click on network analysis, and second you have to select here model. Click on OK. Solution type HFSS, and below in the options click on network analysis and click on model. Then once it is done, click on OK. Up to this everyone have done, right? Shall I move to the next step?
Yes.
Okay. So now I hope you have renamed this as a port. So select this port now. This color, once I'm selecting this port, you are able to see selected region. Right click, assign excitation. Right click, assign excitation. In front of port, select lump port. Lump port. I hope you have got this pop-up window. So we have to select always impedance 50. Click on next. Now one more pop-up window will come. Here, mode 1 integration line, none is there. We have to select here new line. Just click on that none. New line you have to select. I hope you have got this this kind of structure. Now integration line, new line. From this point, just anywhere in this line, click on the at one. Just stick to the next line. If you're not clicking on the top line, it will show you invalid. So once again I'll show you. I have selected the code. Right click, assign boundary. Sorry, assign excitation code, lump code. 50 ohm impedance, integration line, new line from the bottom to the top. You can see inside this defined game. If it is not properly connected to the other line, it will show defined inside bracket invalid. Okay. I hope you have defined the excitation. Done. Now, since this is 2D geometry, we have to assign the boundary conditions also. So wherever copper conducting part is available in this whole design, you can see inside the sheet we have lumped port and below unassigned option is coming. If we are not giving any boundary condition, we will not able to run the simulation. Since this is a conducting material, we have to assign boundary condition for the patch and ground plane, perfect electrical boundary condition. Again, select the ground. Just click on the ground, right click, assign boundary, perfect E. So you can see now inside this unassigned only one patch is remaining, and under this perfect E ground plane is selected. So you can see here ground we have applied boundary condition. Right click on the rectangle, assign boundary and perfect E. Same way we have to now do for patch. Understand मध्ये jump कोण आलाय? Board मध्ये understand आहे. लेफ्ट साइडला प्रोजेक्ट मॅनेजरच्या विंडोमध्ये परफेक्ट ई प्रोजेक्ट मॅनेजरच्या विंडोमध्ये याच्यापासून आले काहीच आहे त्याला डाउन करा आणि ते I hope you have done patch and ground design. But next step to create a radiation box. अपन आले तो चंबर मध्ये ideal conditioner radiation box 0 consider करतो ना. Have you completed this boundary condition part? So next one, this antenna we have created for 2.4 gigahertz operating frequency. So we have to create radiation boundary box for 2.4 gigahertz operating frequency. Before, what we used to do analysis, we used to take a box and then we have to take a distance lambda by 4 at all 4 directions. Like calculation we used to do and create a geometry accordingly. Now it is little bit easy. Just go to the plane, right click over here and click on create open region. One pop-up window will generate and it is asking you at what operating frequency you are going to create a radiation box. So here type, remove that operating frequency 1 and type there 2.4. So for 2.4 gigahertz operating frequency, see, now you have created the conditions for the patch and ground. Now the next step is to create a radiation box. So anywhere in the plane, just right click and click on create open region. Okay. So this no need to click on ground plane. यहाँ पे white color कहीं पे है, वहाँ पे कहीं पे जाके you have to just click on, just right click and select here create open region. This pop-up window will generate and remove this one, type here 2.4 radiation boundary. You have to select over here and click on OK. Press Ctrl D. Radiation box will be created automatically for this operating frequency. 2.4. Since our antenna design operating range is 2.4, for same we are going to create a radiation boundary also. Exactly at the middle, our antenna is there. And lambda by 4, it at each length with height. Software automatically created. Now go to HFSS and click on the top, go to HFSS and click on validation check. One error will come. Barabar? Check by validation check completed error one. It is asking us analysis setup. We never gave operating frequency to the antenna. Only we have created boundary for the 2.4 gigahertz frequency. Again, go to analysis here. Here in the project manager, below this mesh analysis option, you can able to see. Right click, add solution setup, and advanced. The pop-up window will generate. Here we have to write the details. Operating frequency 2.4 gigahertz. Number of pulses you can increase up to 18. I'm keeping 6. And delta S value always keep 0.02. Also, advanced. Right click analysis advanced. Then type there 2.4 operating frequency. Here inside this linear count 1.2 gigahertz to 3.6 gigahertz. Number of points I'm going to reduce. Shall I repeat? Yes. Now just right click on analysis, add solution setup, advanced. This window will come. Here type operating frequency, remove 5 and type 2.4. Number of maximum number of passes you can increase up to 18, 18. I'm keeping 6. Then maximum delta S is 0.02. Up to this everyone have done, right? Click on OK. One more pop-up window will generate. Here you have to check two things. In the distribution it is linear count. Now it is asking us range of frequency. Our operating frequency is the mid frequency. The software automatically have taken 1.2 gigahertz to 3.6 gigahertz. If you want to draw it from 1 gigahertz to 3 gigahertz or 1 gigahertz to 4 gigahertz, you can type accordingly. It's up to you. Otherwise, keep as it is. Now, points it is showing here 401. So, from the range of frequency 1 gigahertz to 4 gigahertz, since I have selected that 1 gigahertz to 4 gigahertz, it will give me 401 operating frequencies like 1.1, 1.25, like that. It will give 401 values. Automatically, your simulation time will increase. So I don't want this much of points. I am keeping 101. So I'll get from 1 gigahertz to 4 gigahertz 101 values. Then below 3D field save option is there. I want to see radiation pattern also. That's why just click on save fields and save radiated field only. These two ticks you have to do over here and click on OK. So now I hope up to this everyone have done that. Sometimes what happens if unknowingly these points you forget to click. In that you have to give manually 3D and elevation plane and azimuth plane values. What are those? So suppose anyone forgot to click on this, then in this radiation below this field overlay, these three options you could able to see 3D, azimuth and elevation. These options will not generate in that case if you didn't click on that. You can do manually also this point. You can add this point manually. Right click over here, far field setup, infinite sphere, and here phi and theta value you can assign. For 3D value, you have to start with phi value minus 182 plus 180, theta value minus 182 plus 180. Okay, this is for 3D. You can see, you can now check in your PC. Inside this 3D, double click on 3D. You can see this theta value minus 182 plus 180. Again, phi value minus 182 plus 180. Now, in case of azimuth plane, you can see phi value is minus 182 plus 180. Theta value, it is started with 90, stopped with 90. With step size, you can keep 1.
Where it is 90?
In case of azimuth plane, theta value you can keep as it is.
How to go for this radiation pattern setup?
Automatically it has actually generated. If I forgot to click on that tick, we have to do it manually. That part I'm telling. So now you can directly go to the HFSS and validation. You do all design setting, 3D model, boundary condition, everything is correct now. You got an all green ticks. You can run the simulation. Again, go to HFSS and analyze all. दुसऱ्या डिझाईन कम्प्लीट करायचं कसं करायचं.
काही झालं नाही. तुम्हाला आलं ना?
So again you have to check now results. Right click over here on the results. Create rectangle. Results. Right click. Create model solution data report. In that select rectangle plot and click on new result. Your S parameter will generate here.
Create on.
Once repeat ma'am.
टू पॉइंट टू वाला सेटअप ऑप्टिमायझेशन करावं लागेल. थोडेसे पॅरामीटर मध्ये चेंज करायचं. ठीक आहे. स्टेप समजला तरी पास आहे. We have to just plot now a gain plot in that. Just go to again results, right click, far field reports मध्ये we have to select 3D polar plot and click on db gain total dbc.
कसा यायला पाहिजे
असा नाही येत.
कसा आला फर्स्ट रिझल्ट नंतर काय रिझल्ट
Plot.
पॅकेज माझा असा आला मॉडेल सिलेक्टेड आहे पहिला आता काय
Who got exact S parameter resonance? कोणीच नाही घातलं. पहिला असं आला first. हा correct आहे. त्याला pause करूया. नको बोला.
मैम कहाँ पे जाना है?
Result में जाओ, right click करिए.
हाँ. Then उसके बाद
Create terminal solution data report. उसमें आपको rectangle plot select करना है. Terminal that category select terminal as parameter and S11 and DB. Click on new. Sir, rectangle plot में click करिए. Right click on results. Data solution.
Solution awarded मतलब म्हणून प्रॉब्लेम आहे.
Create terminal source data report in that select the rectangle plot. Click on that. Select here new report. Click on new report. Okay, you also want to connect. Like this is correct. Get a resonance. Simulation design में system time में फर्क पड़ेगा पहले ना. System time में फर्क पड़ेगा simulation में करून बघा. आता executive time आहे ते plot.
ती सगळ्यांची टायमिंग वेगवेगळे असणार आहे.
मॅडम आपके इसमें टाइम क्या है?
सिस्टम टायमिंग की काय फरक पडेल? डेट आणि टाइम चेंज
We have very less time. I'm just moving towards the reconfigurable part. So in that, what we are going to do? So right click again on result. Create far field report in that 3D polar plot. आणि 2D पाहिजे असेल तर ऍडिशन पॅटर्न वर क्लिक करायचं. अनुष्का. You can see here this is the 2D. 50 आणि 590. आता one concept I want to show you about the reconfigurable antennas. First, I will start with transmission line. The transmission line, you can see this is, suppose at this point I have started exciting this line. So current will pass through this. Now in this case, I want to keep one diode over here. So diode, when diode is in forward bias, it will be the voltage across this is 0.7 volt. And when it is reverse bias, in that case, it will act as a open switch. Similarly, same concept we are going to create on the transmission line or in antenna also. So I just wanted to show you concept, same you applied with the antenna. So here, basically, we are going to create a slots. This is C1, C2, this is R, and this is L. Now, using these slots, we can play with forward bias and reverse bias. When diode it is in forward bias, in that case, our circuit will be inductance series with resistance. In case of reverse bias, and when it is in forward bias, in that case, this resistance will be very minimal in terms of ohms, very less resistance. And generally, I am keeping this as a 4.4 nanohenry. When it is in reverse bias, in that case, this inductance will have again the circuit would be for this resistance one capacitance will be in parallel. So this is RT, CT, and this resistance value will be more, like 10K, 15K, like that. And this is 32 picofarad. Okay, this kind of structures actually we are going to create or using the microstrip lines or patch or rectangles. So what exactly we are going to do in HFSS? After creating the geometries, we have to assign the current flow. So first, this is the transmission line I have created. Again, there will be ground plane and all those stuff. Here, this is C1, C2, R and L. Now I want to create a forward bias. Two conditions will be there: on condition, off condition. Now in case of this applying boundary condition, you have to select any slot and like that boundary condition towards the reverse direction. Whatever, reverse or forward up to you. If you are selected like this, you have to select all slots like this. If you are selecting arrow at forward direction, select all the boundary condition forward direction. Otherwise, mismatch will happen. I'll show that part. So when diode is on condition, your resonance will be different. When diode it is off condition, your resonance will be different. I'll show you for transmission line. Similar way, this is for one diode. You can create for varactor diode also, but internal structure of the varactor diode you have to check, and accordingly you have to put the boundary conditions. I will show you one example where 3 diodes will be there. The structure of that antenna is like this.
And it's a pin diode or it's a normal diode?
Yes, it's normal pin diode. Varactor diode also you can add. This is the pin diode, simple pin diode. For varactor diode, there is a different slot structure. Suppose this is one structure I have selected. So suppose I want to add 2 diodes here. So at this point, one diode, and this point, one diode. So in that case, I will have 4 conditions. When 0, 0, 0, 1, 1, 0, 1, 1. So all 4 conditions, you will get a 4 different S parameters. So you have to select which is the best out of that. You have to run the simulation and check. So when both are off, it will look like this. Slot will be there, like additional capacitor will be generated in this design. If one is on, you can see it is connected at this point. So this conducting part will be like this. At this point, you have additional capacitor. If this diode is on, diode D2 is on, then the conducting part will look like this. And when both diodes are on, your structure will look like this. So likewise, I will show you for 3 diodes. So there will be 8 possible conditions. First, I'll show you transmission line. I hope you have understood the concept behind this. How to create a transmission line, reconfigurable transmission line basically. We have to create here C1, C2, R and L. And then in that you will have 2 conditions, forward bias and reverse bias. In the forward bias, you have to create a boundary condition in this structure where L is series with R. And in the reverse bias, you have to create a structure using this only. I will show how boundary condition. In the boundary conditions only, you have to select this kind of structure. Here, L is series to the parallel structure, RD parallel to CT. And again, this is series to LS. So likewise, structure will be there for reverse bias. is the transmission line I have created. And when both diodes are on, I'll show you boundary conditions part because designing part you can anyway do. When diode, you can see these are the 4 slots I have created over here. As I showed in that figure also, C1, C2, R and L. So in the boundary condition, what we have to do? Right click, assign boundary, and lumped RLC we have to select. I already selected, that's why this error is coming. So you can see this is the C1. So in that RLC boundary condition, you have to assign the particular component. So I have selected here below capacitor, that value I have given 32 picofarad, and it is series connection because diode is on condition. Similarly, C2, this is for C1, C2 also the same way, series, capacitance 32, and this is RLC boundary condition, click on OK. The next 2 points are register. So since it is series connection, resistance value will be in forward bias, register will be very less. So I have selected in 4.7 ohm only, since it is in forward bias. Now, in case of inductance, same way, inductance value is 0.4 nanohenry, and again the connection is series. Now let's see for the off condition. So in the boundary conditions only things will get changed now. In case of resistance, it will come parallel, and with the resistance you have to select here 10K parallel to the capacitance 32 picofarad. Remaining things will be same. And just run the simulation. I hope it is clear now. Only the forward bias and reverse bias in boundary condition RLC you have to do change in reconfigurable part. Now I wanted to show you about one antenna.
Can we cover the configurable antenna different steps?
They asked me to finish by 4:30. It will take a lot of time. I'll do one thing. ADT file of this file I'll share to madam. You can download student version, and she'll share this design via email. You just open it on your student version and run the simulation. ANSYS has a student version, free student version. I'll share link of that student version to the madam. 10 GB software it is. 3 months you can access, and again after 3 months you have to reinstall. In basic level experiments you can perform in student version. No need always license version is required. So you can perform antenna design experiments using student version. That won't be an issue. This is a free version only. License version it will take some 10 lakh cost for 1 year, but student version is always free. Just reinstall for 3 months.
Can we have the complete result analysis by using student version?
Yes, you can get it. Only the drawback, after 3 months you have to reinstall it.
Okay, so
But all basic level experiments you can perform in student level. Student version. Only advanced version like antenna placement on car or some big designs you can't perform. Small designs you can perform. And for that purpose, I have shown you ACT extension, right? So that ACT extension, go to view. So go to view, and here click on ACT extension. So one pop-up window will come here, ACT extension. There it is. Inside view, go to view, click on ACT extension. Then this ACT extension pop-up window will come. Inside, click on launch wizard, and HFSS antenna toolkit you have to select. Shall I repeat? Yes. Okay, ACT extension window came. Launch wizard window came. Click on launch wizard. Then you can able to see on the screen 5G Wizard, HFSS Antenna Toolkit, HFSS 3D, EMA 3D, and Maxwell. In that, click on HFSS Antenna Toolkit. So you can see these are the different, more than 22 types of antennas are available. Helix antenna, inside that axial mode, then normal mode. In horn antenna, you have conical horn antenna, E-plane, sectoral, H-plane. Click on that rectangle shape. You could able to see some antennas right there.
Yeah, helix is there. But
Am I in that FIPA antenna there? Just click on that.
FIFA is there.
So more than 21 types of different antennas are available over here.
Okay.
What things you have to do?
Sorting pin, sorting pin.
Many things are there. Just any one antenna select here. Let's suppose wire dipole. In the center frequency, type any operating frequency which you are interested to design. So I'm typing here 1 gigahertz. So 1 gigahertz, if you are selecting here, according to, just click on synthesis. Accordingly, antenna dimensions are getting changed over here. Any operating frequency you keep there and click on synthesis. Accordingly, antenna dimensions you can able to see. What are the antenna dimensions for the wire antenna? Here, dipole length is important, dipole radius is important, and speed gap is important. So all three parameters you could able to see, and how this wire antenna look like, that also structure you can able to see.
It is for dipole. Okay, that is for wire dipole. What is it?
Wire dipole.
Okay, I have taken planar dipole in that it is
No issues. Below there in Balani, at exactly at what is the reference they have used, that also they have mentioned. And once it is done, click on finish. That geometry automatically will create over here with all the steps which we have already done, like geometry creation, applying boundary condition, solution setup, apply application, radiation bound, everything.
for gigahertz which we studied here. So
That also you can create. You can check.
already available.
Yeah, it is there. You have to just go and check. And
We
just
don't need to we don't need to derive the dimensions and all
no,
that.
automatically it will create. But these are standard antennas. If you want to do some modifications in the antenna, then these antennas will not help you. You have to again do by yourself. So you can see it has generated result also.
Can you give some video or steps for reconfigurable antenna?
It is there available. Just type on Google reconfigurable antenna. For one of the webinar, one recorded session, you could able to see my face. I think one of the YouTube channel they have recording. A reconfigurable antenna, it is there. So, ARK additive, some channel is there. In that you can see that all steps are there for the reconfigurable. And every month I'm doing free webinar, and you will get certificate also from our end. For this month, we are going to do antenna matching using Smith chart. HFSS tool we will use, and that webinar will be on 28th of this month. I'll tell you the timing. I need your email details so that you have to register for that actually. I'll show you registration. You can scan this now and you can register.
मॅडम वेबिनारचे नोटिफिकेशन कुठे येते
हे स्कॅन करा रजिस्टर झाल्यानंतर तुम्हाला येईल.
फक्त ह्या वेबिनारसाठी ना असे तुमचे
आम्ही प्रत्येक ईमेल म्हणजे तुमचा जेव्हा रेकॉर्ड आमच्याकडं ईमेलचा डेटा येतो तर एव्हरी टाइम वी विल इन्फॉर्म यू. होते ना स्कॅन?
कशाचं करता रजिस्ट्रेशन?
हा वेबिनार आहे 28 तारखेला अँटेना मॅचिंग युजिंग स्मिथ चार्ट. ते त्याच्यात मी त्या वेबिनार मध्ये कंडक्ट करतो. हो मीच केलं. Registration you can do. We'll get free certificate. There is no any charges for this webinar. It's free.
लिंक मला पण फॉरवर्ड करते का व्हॉट्सअपवर शेअर करते?
मी करते तुम्हाला.
ज्यांचं नाही झालं किंवा जे झाले नाही ते पण करते.
आणि स्टुडंट व्हर्जनची पण लिंक देते.
हो मी पाठवते.
आणि हे रिकॉन्फिगरेबल ट्रान्समिशन लाईन पण मी ऑनचं देते. ऑफचं तुम्ही स्वतः करा. सेव्ह ॲज करा ते डिझाईन. आणि ऑफ कंडिशन साठी जसं मी सांगितलं यू हॅव टू चेंज द बाउंड्री कंडिशन्स. You can take a reference of YouTube recording and you can do that. फोल्डरमध्ये ठेवून घे ना.
झालं ना ते लेटर मला हे कशासाठी रजिस्ट्रेशन आपल्या ग्रुपवर उद्या कोण आहे किती दिवस एवढं छोटे
That you should know, no? Your identity because see, if I want to go for action mat in my profile, I'm checking for how much the plate was. It will change like what kind of application you are looking after.
सर वो आर्टिकल जो सोशल तीन पेजेस
एकच पेज आहे प्रत्येक पेपरसाठी एक पेज बघेल कुठे
इसी पे हमने करा था तो कल सूर्य का आर्टिकल डिस्कशन का सब पूछना था ना टेक अवे
त्या आर्टिकल मधून काय आहे टेक अवे म्हणजे तुम्हाला त्या आर्टिकल मधून काय मिळालं तुम्ही काय म्हणजे आम्हाला जसं तुम्ही म्हणू शकता की वी हॅव गॉट डिझाईन इक्वेशन फॉर पॅच अँटिना फॉर एक्झाम्पल we have got gain parameter how to calculate gain parameters for antenna असं this is take away ते टेक अवे म्हणजे त्याच्यातून जे शिकायला मिळालं आपल्याला आणि डायरेक्ट मिळालं की हे यूज करून मी काही काम करू शकतो तर ते म्हणजे टेक अवे प्रिन्सिपल वन म्हणजे ते टेक्निक्स त्याचे ज्या यूज केलेल्या आहेत
जर एकच असेल तर एकच
तर दोनच असतील तर दोनच एकच असेल तर एकच हा टेक्निक त्यांनी यूज केलं आहे
चारही पेपरचं करायचं इंडिव्हिज्युअल सबमिट करायचं
हा चारही पेपरचं करायचं
इंडिव्हिज्युअली की
ग्रुप मध्ये आहे
आपने को चारही सबमिट करताना इंडिव्हिज्युअली करायचं ग्रुप वाईज
एंड करू द्या ना बसा प्लीज हां
I'm talking about antenna designing part. So I feel you are having that modulation, demodulation part in your mind. So somehow you wanted to show your knowledge on it. कहाँ पे designing
बंद करायचं
सिलेक्ट करायचं.
कोणता अंतर नाही